Okay, example number 4 is also another word problem. Reading thoroughly, it states, River C is 600 miles longer than River B. If the sum of their lengths, so if you add the two rivers together, the length will equal a total of 5,580 miles. The question is asking, what is the length of each river? We have to pick out something that we do know. We know that River C and River D are the variables being represented in the equation. So I will represent River C with X and River D with Y. Once again, that's just me picking. You're able to choose any variable that you want to represent these two rivers with. So reading through the first sentence once again, it says River C. I know that River C represents X. River C X is means equals, is a total. 600 miles longer, so it's 600 miles more or further than River D. But since we do not know the length of River D, we represent River D with the variable Y. However, River C, it states, is 600 miles longer, so plus 600. So the equation we have written states that River C, representing X, equals 600 more than River D, which is Y. Now let's read the second sentence. If the sum is addition of their lengths, so if the sum of both of these rivers is a total of 5,580, what is the length of each river? So we need to write an equation with this statement saying if the sum of the two rivers, so if I added these two rivers, if I added River C, which is X, to River D, which represents Y, and the length is a total of 5,580 miles, what is the length of each river? Okay, we have now written a system of linear equations. When we solve for X and solve for Y, we will then know the length of each river. We are going to use substitution to do this. You can notice that we will use substitution because we have already have one variable isolated on the left side. This is stating that X equals Y plus 600. Therefore, if I were to use this equation, I'm constantly asking myself, how do I change an equation that has two variables and two equations into one variable equation? I do so by substitution. Because X equals Y plus 600, I plug in Y plus 600 for X. Continuing, bringing down everything else in my equation. Once again, using the 5 rules, there is nothing to distribute because there is not a number on the outside of the parentheses. So I will simply write and then move on to Rule 2. Rule 2 states to combine like terms on each side of the equal sign. So I look on this left side of the equal sign and I have a like term of Y. So 1Y plus 1Y is 2Y plus a constant of 600 equals 5,580. Moving on to my third rule states to have the variables on the left side of the equal sign. I pick out my variable, which is Y, and I notice that it is on the left side. So I'm moving on to step 4. which states to have the constants on the right side. Well, I see that my 5,580 is on the right side, but I notice that my constant of 600 is still on the left. So in order to move the constant of 600 to the right side, I will do the inverse of what they are doing. They're adding 600, therefore I will subtract 600. What I subtract from one side of the equal sign, I must do to the other side of the equal sign. Minus 600 will cancel out. Bringing down what I've not used is my 2y, and subtracting 600 from 5,580, which will be 4,000. Let's borrow. Cannot borrow. 7. Become a 4. To become a 10. So 10 minus 0. Excuse me. No, I have to borrow right there. I'm so sorry. I'm struggling with simple math. Back to this subtraction problem. You do not have to borrow. 0 minus 0 is 0. 8 minus 0 is 8. 5 minus 6. Now you cannot take 6 from 5. So you borrow from the 5 to make it 4. And this becomes a 15. 15 minus 6 is 9. And 4 minus 0 is 4. So this represents 2y equals 4,980. My last step is to get y by itself by multiplying or dividing. I do the inverse of what they are doing. Because they are multiplying y by 2, I'm going to divide by 2. When I divide by one side, I must do to the other. 2 divided by 2 cancels out, leaving me with just y. And when I divide 2 into these two equations, this will give me and that is correct. Therefore, once again, all of this work has been completed and I have only solved for one variable, but from here on out, it gets easier. So using either one of these two equations, I will plug in y into the simplest equation. I'm going to use x equals y plus 600. And my y, once again, is 2,490. X equals 2,490 plus 600. And when I add those two together, I have that x equals 3,190. Now I have y equals 2,490 and x to equal 3,090. I still do want to check. So when I check, first I want to write this as an ordered pair. My x being first, 3,090, and my y to follow. So plugging into these two equations. My first equation, x equals y plus 600, and my second equation, x plus y equals 5,580. So I know that, once again, x equals 3,090. And my y representing 2,490. So I'll bring down what I have on the left side, and then I will add my two numbers on the right. $3,090 equals 3,090. That does hold true. Therefore, this ordered pair x, y is a solution to the first equation. But we know it has to be a solution to both equations in order for it to be a solution to the system. So I'm once again plugging in 3,090 for x and 2,490 for y. And I will bring down what I have on the right side. When I add these two together, on the left side I get 5,580, and of course on the right side I bring it down, which equals 5,580. I have proven that and found to be that the ordered pair 3,090 and 2,490 is a solution to the system of linear equations.